Hey guys, welcome back. We're going to talk about acidic and basic properties of oxides. And so these are compounds, obviously, with oxygen in them. All right, so when they have oxygen, right, are they acidic? Are they basic? All right, and so a lot of group 1 and group 2 metals, right, are basic. And there's a couple other ones, right? There's a couple other ones. One with indium. So indium 3 oxide and thallium 3 oxide. Those are also basic, as long as the group 1 and group 2. We'll get to beryllium in a little bit. But the rest of them, because beryllium's a little bit different, but group 1 and group 2 are pretty much basic oxides, and they're pretty much going to go with the oxide. They're going to react with water and form their hydroxide. All right, so basic metal oxides with water form the hydroxide. The nonmetals, when the oxidation states are large. Well, what do we mean by that? So the oxidation state of carbon here is +4. Sulfur would be +6. Right? You got 10 +5 here. Right? So these are bigger numbers. Right? Not +1 or +2, but they're kind of big. So that means these acidic oxides, they're going to basically react with water and lower their oxidation. Well, they actually don't change their oxidation state, but they just react with water to make an acid. All right. Now, no nonmetal oxides have shown to have basic properties. So all these nonmetal oxides, they're not going to be basic. Now there are some like carbon monoxide and nitrogen monoxide. They're not going to be acidic. Carbon monoxide is not necessarily going to be acidic in the terms of what we're talking about. All right. So then we have acidic oxides and bases. And the acidic oxides that we have, with their bases, they tend to look just like a normal neutralization reaction or normal acid-base reaction, where you have your acid, your base, your salt, and your water, right? So that's a typical neutralization reaction, right? You get your base, got your acid, get your salt, got your water. All right. So now, aluminum oxide is amphoteric, right? What does that mean? That means it can act as both acid and as a base, right? It can do both, right? And so aluminum oxide here, if we put our aluminum oxide, it's a base here with an acid. It makes aluminum chloride and water, right? Salt and water. As an acid, it's going to react with a base. So here's an acid, aluminum oxide acid, with a base of sodium hydroxide and water, right? And it makes an adduct, all right? Kind of neat. Now, silicon dioxide, all right, is insoluble, right? Which makes sense. Sand is pretty much insoluble. However, with very concentrated hydroxide solutions, right, it'll be react with a base and be an acid. Okay, it'd be acidic, right? It can have acidic properties. Now, this is why, when you have like concentrated sodium hydroxide or potassium hydroxide, right, or anything, we don't put glass in the base bath, right? Okay, so we used to clean glassware in grad school, right, and we do the base bath, and it was an isopropanol solution with like potassium hydroxide, and it would just clean things like you can't believe, right? You don't do this at home, but we never put quantitative glassware in there because it changes the volume, right? It had to be just like beakers and such. It wasn't, right, very concentrated glassware, or glassware that monitored concentrations like volumetric flasks and pipettes and that type of stuff, right? Because the glass would react, right? This is the main component of glass. Pyrex and other things that have, boron in there and other proprietary chemicals to make it a little stronger and shatter resistant. But that's the main component of glass, and it reacts with base. All right. Then we have pretty much the transition metals, some of the transition metals, all right, with high oxidation numbers. So you got manganese here, right? That would be manganese 7, and you got chromium 6 here. So manganese 7, chromium 6, so this is plus 7, this one's plus 6, right? As oxidation states, those are pretty large. So when they react with water, they make their acids, like permanganic acid and chromic acid, right? And then we have some amphoteric oxides, all right? And so what does this mean? So aluminum and tin and lead, some of these guys, they're a base because they have hydroxide with them. No, I have oxides written down. These are hydroxides. Let's change that, shall we? All right. And so all these they have hydroxide in them, as you can see. However, all right, so if we look at beryllium here with hydrogen, it's just what you expect. Oh, the H's react with OH and you get water. However, when the pH is sufficiently high enough, right, when there's enough of these in there, and it depends on the compound, right, it'll make this complex ion, right, and beryllium hydroxide will actually dissolve to make this. Same thing with aluminum. Aluminum hydroxide plus more hydroxide will get you here. And I forget the pH range. It's like above 10 or something like that, or above 12. Right? There is, most of the time, aluminum hydroxide is insoluble. But if you have enough acid, it dissolves. Or if you have enough base, it dissolves. That's kind of neat, just some of these properties of these oxides on the periodic table, right? And so if you look, most of the non-metal oxides are acidic. There's a few that are amphoteric, and then a lot of the oxides of group 1, group 2 are basic. All right, so hopefully that works out for you guys. If you have questions, let me know, and we'll see you in the next one. Take care, guys.